We're going to walk through the tool Gephi using a network of characters from the play Rosencrantz and Guildenstern are Dead. While some scholars have questioned the value of using network analysis on fictional networks, we thought it might be an interesting counterpoint to Franco Moretti's analysis of characters in Hamlet. If you're interested in learning more about the concept of network analysis, please see the previous video. To begin, download Gephi for free at gephi.github.io. After loading Gephi, open it and start a new project. It will open the Data Laboratory and the Graph tab. To make a network model, you need a CSV file with a column for source and for target for each of your nodes and edges. A CSV, comma-separated values file, is a kind of table which you can make in Excel or text editing software. We have a file where the speaker in Rosencrantz and Guildenstern are Dead is the source column, which we've identified at the top of the column as source, and the character they're speaking to is the target, identified at the top of the column as target. You can also make a spreadsheet using just the nodes. In this case, that would be the characters in the play, with columns that have more information you want to include in the network, like categories such as players or royal family. But for this example, we'll just be using a basic edge table, a table of relationships. To load network information into Gephi, click on the Data Table tab, then click Import Spreadsheet. Select your file and make sure it's set as the right table, edges or nodes. Ours is an edges file because it includes the relationship between two things. You can see if the source and target are accurate, then click Next. We check Create Missing Nodes just in case there are missing values in our spreadsheet, then click Finish. You'll see now, under the Nodes tab of the data table, we have the characters included in our table listed. Under Edges are the directed relationships. You'll notice a column with weight has been automatically generated. This tells us how many edges are between the two nodes. Next, we can look at a preliminary graph and run some analysis on our network. Click Overview. Let's make labels on the network visible. Click on Attributes, which looks like a clipboard page at the bottom center. We'll check ID because we don't have a separate label column in our data. Then click on the black T to the left of the center to show the labels. You can choose different elements to show using the icons at the bottom of the page. You can change font size, choose to show or not show edges, and change the relative edge thickness. You may wish to change the layout of your visualization as well. Keep in mind that layout appearances are governed by mathematical models, and some may be better suited towards your network than others. Let's choose the Fruchterman-Reingold layout and click Run, then Stop. You may wish to adjust the settings for the layout. In this case, let's change the area to 20,000. This model is using concepts such as gravity and speed as metaphors to illustrate the relative distance between nodes. Our network model doesn't seem particularly surprising. Rosencrantz and Guildenstern are overwhelmingly connected to others and to each other. However, consider the potential research question. Are Rosencrantz and Guildenstern interchangeable? This seems to be the implication from the play Hamlet. Let's take a closer look at the relationships between Rosencrantz, Guildenstern, and other nodes. The two seem to have the strongest bond with the player. Look closely at the edges between the three. The edge between Guildenstern and the player is thicker than the edge between Rosencrantz and the player. We can check the exact differences by looking at the Data tab. This could lead you to look back at the play and re-examine the two sets of relationships for key differences. Gephi allows you to run statistical algorithms to give you control over your visualization. Under Statistics on the right, you can run various analyses. Mouse over the name to see what each analysis does. Let's run Modularity, which is used to detect communities. It will classify all your nodes into groups. Feel free to close the report which pops up. On the left, we can now modify the visualization of the data and analysis we ran. You may need to hit the green refresh button for new options to appear. Let's click on the Partition tab, the Nodes option, and select Modularity class. Click Apply. You can see how Gephi has separated the characters into communities by color. Once you've formatted to your liking, options for exporting your Gephi graph are under the File menu. Network analysis can be useful for scholars at various stages of research. If you're just beginning to explore a text, a network analysis can help drive you towards a research question by pointing out unexpected relationships. If you have designed your network analysis with a question already in mind, the results can provide some evidence to argue for or against a thesis. In our case, refuting the idea that Rosencrantz and Guildenstern are interchangeable. In either case, performing this kind of computational reading can help you understand your corpus or text better simply by preparing it for analysis. Find other Gephi tutorials, documentation, handouts, and forums at gephi.github.io.